hypothesis. Today we are going to learn about testing of hypothesis. Now first we have to know the term population. A collection of objects under study is called population. Means the observations which are under study, that whole observation is called population. In other words, the universal set of objects having some common properties is called population. That some kind of characteristics having a particular group is called population or universe also. The next term, that was the sample. A finite subset of population is called as sample. Sample means what? From the whole population we have to take a sample means if we have 100 students and we have to check their performance level, then we choose the 10 student out of them, then that's called sample. 10 student, this is our sample, and 100 student, this is our population. For example, another example, in our daily life, to test the milk, we have to just take cup of milk and taste it, not all over milk. Also, to check the rice is cooked or not, we are checking by taking a single rice from the whole jar, and check that this rice is cooked or not. After that, we are going to know about parameter. Parameter means what? The unknown constant of a population on the distribution are called as parameter. Let f of x comma theta be the PDF of a random variable x having an unknown constant theta, where theta is called as the parameter of the distribution. Parameter means what? The unknown constant of the distribution is called parameters. It is denoted by theta, lambda, delta, like that. After that, we are going to know about hypothesis. Hypothesis means assumption. An assumption about the unknown parameter of the population or the distribution of the population is called the hypothesis. It is also called as assertion, axiom, or premise. In other words, hypothesis is a statement or claim regarding the characteristics of one or more. Hypothesis means what? Hypothesis is assumption. If we have to consider that the salaries of the salaries of the south companies is more as compared to Indian Maharashtra, then we are assuming that all over companies in south are, if we know or check that the two or three companies having highest salary, and considering that all over south companies having highest salary as compared to Maharashtra, then that statement is our hypothesis. Then again we know that there are two types of hypothesis: simple hypothesis and composite hypothesis. Simple hypothesis means a hypothesis which specifies completely the parameter of the population or the distribution of the population is called simple hypothesis. Simple hypothesis specify करतं all information about the parameter. For example, if x follows binomial distribution with parameter n comma p, where p is specified, that p's value is which we are known, and also x follows normal distribution with parameter mu comma sigma. The mean height of in Indian male of age 20 is 175, where mu is equal to 175 is simple hypothesis, where the mean is mentioned, so we know the parameters value, then that is called simple hypothesis. And versus composite hypothesis, a hypothesis which does not specify the value of the parameter or the distribution completely is called composite hypothesis. As we see, in simple hypothesis we know that the value of the parameter completely. In case of composite hypothesis, they do not specify the value of parameter completely. For example, the mean height of Indian male of age 20 is more than 175. That means they are mentioning that the height is greater than 175, that they are not given the accurate height. Also, another example, x follows normal distribution with parameter 100 comma sigma square. Then they are giving the mean value but not specify the sigma square value. That is, they are given the incomplete information. Also, x follows binomial distribution with n comma p, where they mention about the n value but not mention the p value. Or and again they have mentioned that p is greater than 0.25 but not mention the exact value of p. Null hypothesis. In hypothesis there are two types, that is null hypothesis and alternative hypothesis. First we are going to learn about null hypothesis. A simple hypothesis which possible view of rejecting it, it is called null hypothesis. It is denoted by h naught. It is denoted by h naught symbol. Is a h naught is a hypothesis that contains a statement of equality. It is a statement that we want to test. It is always simple hypothesis. It is also called as working hypothesis. The test is constructed under the assumption that the null hypothesis is true. It is the hypothesis of no difference. That is mean the null hypothesis. For example, if we consider that the two or more companies having highest salary, that is mean salary is equals to, or that is highest salary from the south, that is our, and we consider it mu equal to mu naught, that is the null hypothesis. That is the population mean equal to sample mean, that is called null hypothesis. Example, if we were to verify whether the mean height is more than 176, more than 100, mean height is more than 176, then mu naught equal to h naught equal to 175, h naught equal to 175. Alternative hypothesis, a hypothesis which is in last lecture we see about the null hypothesis, and now we see the alternative hypothesis. Whenever we set the null hypothesis, alternative hypothesis is necessary. A hypothesis which is opposite to the null hypothesis is called an alternative hypothesis and denoted by H1. The alternative hypothesis is the statement that contains a statement of inequality such as less than sign, greater than sign, or not equal to. Means if we are setting the null hypothesis as H naught as theta equal to theta naught, then our alternative hypothesis must be not equal to theta is not equal to theta naught, which is also written as theta is greater than theta naught, theta is less than theta naught. It is the hypothesis what we wanted to prove is called the alternative hypothesis. So we see the difference between null hypothesis and alternative hypothesis. In null hypothesis we see that theta is equals to theta naught. There is no difference in between two alternatives. But in alternative hypothesis we see that theta is not equal to theta naught, that the value of sample mean is greater than population mean, less than population means, or not equal to population mean. These are the assumptions. After that we see that if we want to test, the claim was for balanced balanced in bracket unbiased, then h naught is equals to p equal to 1 upon 2. H1 is p is not equal to 1 upon 2. If we want to toss a coin 50 times, the head was observed 40 times, then the probability of getting head, which is equals to 40 divided by 50, which is equals to 0.8. We reject h naught, that is the coin is not fair or balanced. Coin is not fair or balanced, because of we see that probably h naught, our null hypothesis is h naught is equal to 1/2 means is equals to 0.5, and our alternative hypothesis we get that the value is equals to 0.8, which is greater than 0.5. So our null so our assumption, that is the probability is equal 1 upon 2, the null hypothesis probability is equals to 1 upon 2, which is equals to 0.5, is rejected, that is the coin is not fair or balanced. Now we see that the types of errors. In types of errors we see the type 1 error and type 2 error. The first one, we see the type 1 error. The decision of rejecting h naught when h naught is actually true is called type 1 error. Type 1 error means what? The decision of reject h naught when it is actually true is called as a type 1 error. Whenever we set the null hypothesis which is true, and whenever we accept it that decision is our correct decision, and whenever we reject it, then that decision is our wrong decision, and this is also called as type 1 error. And in type 2 error, the decision of accepting h naught when it is actually false, it is called type 2 error. Whenever we set the null hypothesis that is actually false and we accept it, that is called type 2 error. This is our wrong decision. These two terms are called types of errors. Then again we see the size and level of significance of test. The fixed probability of type 1 error is called size of test, and it is denoted by alpha. That is probability of rejecting h naught when h naught is true, which is equals to alpha. The maximum value of alpha. Significance levels means what? Confidence level means what? Whenever we set the hypothesis that the hypothesis and we set the hypothesis and our decision is we know that our decision is about 95% true, and 5% there is error about 5%, then that is called as level of significance. If we want to we set that hypothesis that our hypothesis is our decision is 99% true, then there is possibility of 1% of error, then this is called as level of significance. The maximum value of alpha is called level of significance. Maximum obtainable probability of type 1 error is called level of significance. In other words, the probability of committing a type 1 error is called the level of significance and is denoted by alpha. That is, our decision is true is about 95%, and 5% possibility that there is error. Then again it is denoted by alpha, and again we have to know that about power of test. The probability of type 2 error is denoted by beta, and probability of accept h1 when it is true is called power of test. What is called power of test? Power of test is probability of type 1 error is denoted by beta. Probability of type 2 error is denoted by beta, and probability of accept h1 when it is true is called power of test. Power of test means what? Probability of accept h1 when given h1 is true. ज्यावेळेस आपण एक्सेप्ट करतोय h1 ला, अल्टरनेटिव्ह हायपोथेसिस आपण एक्सेप्ट करणार आहे, कधी एक्सेप्ट करणार आहे? ज्यावेळेस ते ट्रू असणार आहे, त्यालाच काय म्हणतात? पॉवर ऑफ टेस्ट, which is also equals to probability of reject h naught when h naught is false. That is means we reject h naught when it is false. That is equals to 1 minus beta. Power of test is denoted by 1 minus beta. Now we see the critical region or rejection region. The critical region is also called rejection regions. It is the set of all values of test statistic for which the H0 is rejected. The sample space of the test is divided into two parts. One is critical region, will leads us to reject H0, and the other will do not reject H0. Whenever we set the hypothesis, there is possibility that our hypothesis is accepted or rejected. Then there is acceptance regions or rejection region. Whenever we solve any example and their values is greater then where values are lies between that critical region, that is called critical region, that is our rejection region. And whenever its value is in between our range, then it is called acceptance region. If we observe value of test statistics is member of critical region, we conclude reject H0. It is true, it is a not a member of critical region, we conclude not the reject H0. If our hypothesis is H0 as mu equal to mu naught versus H1 mu is not equals to mu naught, and level of significance H0 is as mu equal to mu naught and H1 as mu is equals to mu naught equal to mu naught, and level of significance is alpha, then the critical region is as shown in figure. Then this diagram shows the two-sided critical region. Then half side shows that critical region alpha by 2, and another half side shows the critical region alpha by 2, and middle region shows the acceptance region, that is 1 minus alpha. If we get the test statistics value 1.64 and our range is 1.64, we accept a value of when it is it is less than 1.64, then all the values which is greater than 1.64 are lies in between critical region or rejection region, and the values which is less than 1.64, that is lies between acceptance region. If our hypothesis is H0 as mu equal to mu naught and H1 is mu is greater than mu naught and level of significance is alpha, then the critical region is as shown in figure. Then in this figure we show that there is only one-sided hypothesis, mu is greater than mu naught. In our previous diagram we show that mu is not equal to mu naught, that's why there is two critical regions, alpha by 2 and alpha by 2. And here we know that mu is greater than mu naught, that is one-sided hypothesis, so there is one critical region, single region. And again in second diagram we show that mu is less than mu naught, so this is our second diagram there where we show that the mu is less than mu naught. So when mu is greater than mu naught, we show the critical region at the right hand side, and whenever mu is less than mu naught, we show the critical region at the left hand side. Next we discuss about the p-value. P-value of a test is minimum probability of reject H0 when H0 is true. It is also called as observed level of significance. Probability of rejecting H0 when H0 is true. The p-value of the test is p. This is a probability associated with critical value. The critical value depends upon type 1 error, and probability of type 1 error value can be dependent upon the alternative hypothesis. It can be calculated as p equal to 2 1 minus phi of z, with if phi is not equals to theta is not equals to theta naught, 1 minus phi of z if theta is less than or equal to theta naught, and phi of z is if theta is greater than. These are the all types of alternative hypothesis, that is theta is not equal to theta naught, theta is less than or equal to theta naught, theta is greater than or equal to theta naught. When, for example, if H0 as theta equal to theta naught versus H1 as theta is greater than theta naught, and the test statistic is given by z is equals to x bar minus mu naught divided by sigma upon 1 under square root n, and suppose z calculated is 2.33 for given alpha, the p value is 0.01. Reject H0 if p is less than or equal to alpha. We reject H0 if p value is less than or equal to alpha. now we said we are going to see the one-sided test. If the hypothesis test is h naught as theta equal to theta naught and theta is greater than theta naught, then we reject the hypothesis h naught when the value of the test statistics is larger. Therefore we take a critical region only to the right side of the distribution. Such a statistic is called right-sided test. As we see previously, that is, if there is one-sided test, then it is shows at the right hand side, then it is called as one-sided test or right tail test. And if there is two-sided test, if the hypothesis test is h naught is theta equal to theta naught versus h1 theta is not equals to theta naught, then there is two possibilities: theta is greater than theta naught or theta is less than theta naught. Then both smaller as well as higher values of the test are favorable to the alternative hypothesis h1. Hence we take two critical regions to reject h naught, one for the smaller values and other for the higher values of the test statistics. Such a test is called two-sided test. So there is two types. For in two-sided test, we are taking the critical regions of equal size on both sides, and test is called as unbiased test. If alpha is the level of significance, then the critical region of size alpha by 2 is to the left hand side and the alpha by 2 the right hand side taken. This is called as unbiased test. As we see in diagram, and there is two types of hypothesis, that is theta is greater than theta naught and less than theta naught, then there is two critical regions or rejection regions, alpha by 2 or alpha by 2, and the middle region, that was the acceptance regions 1 minus alpha. Now we are going to discuss about parametric test. Parametric test and non-parametric test. Parametric and non-parametric test is depend upon the normality. Normality normality is depends on the normal distribution. Now first we will see the parametric test. A parametric test is a statistical test that makes specific assumptions about the population parameters such as mean and standard deviation. These tests typically assume that the data follows a normal distribution and that variances are equal among the groups. To test it is parametric or non-parametric, there is Kolmogorov-Simron test to check that the hypothesis is parametric or non-parametric. In parametric test, there are t-tests for compare means between two groups, independent t-test or pair t-test. ANOVA is second method, compares the means of three or more groups. One-way ANOVA compares means of three or more independent groups. Two-way ANOVA examine the effect of two independent variables. Then again, test of variances. To check the test of variances, we use F-test, compare the variances of two population. Levenius test checks for homogeneity of variances. Again, non-parametric test, it is a statistical test that does not assume a specific distribution. For example, normality for the data. These tests are useful when the sample size is small. When non-parametric tests are used, when sample size is small, the data is skewed or non-normal, the data is ordinal or ranked instead of interval, the variances of groups are not equal comparing two groups. And in non-parametric test, there are include Mann-Whitney U-test, alternative to the independent t-test, compares two independent group, which is alternative for parametric t-test. Parametric t-test alternative in non-parametric test, that is Mann-Whitney U-test. Wilcoxon-Steinrank test, that is the alternative for pair t-test. And comparing more than two groups, that is Kruskal-Wallis test, alternative to one-way ANOVA, compare three or more independent group. Friedman test, alternative to repeated measure ANOVA, compares three or more related samples. Test for goodness of fit and independence. Chi-square test for independent, check if two categorical variables are related or not. It is most important test and most widely used test, that is chi-square test for checking independentness. Kolmogorov-Simron test, that is compares to distribution to see if they are significantly different or not. Thank you.